Hello, I'm JW. This is part 2 on the LED tape, and this time we're going to actually have a look at this, cut it up and solder wires to it and so on, and obviously see it actually working. And this is part 2. Part 1 obviously covered the basic idea of how it's wired up, so link to that will be in the usual place. But let's have a look at this anyway and see what we can do with it. Now let's have a look at actually using this stuff. So this says the RGBW, which has 5 connections there. And first thing I'm going to do is to cut it to an appropriate length, and you can cut it at these points here, wherever those sort of gold coloured pads are. So it's sort of been cut there at the end, so cut it to the sort of nearest length of whatever you're going to fit it into. And if you're going to be using this, I'd suggest strongly that you actually measure the installation first and then actually cut this and fix it up separately remote from there. You don't particularly want to be soldering stuff up in a customer's house or something like that, though that can be done. Generally easy to cut it in the lengths provided first. Now if you look along the lengths of these, you'll see that most of the pads are gold, but every so often you'll get one of these which actually is this silver colour. What's happened here is that this stuff is only made in about 12-inch lengths, and then in the factory it's actually soldered together in these positions here. So there's one solder point there, and if we go further along, there's some more gold ones, and if we go along far enough, yeah, there's another one with the solder points on it. So you can cut it there as well. It's just the fact that that was already a break anyway. It's just been joined like that in the factory. Now when it comes to actually cutting this, the easiest way is just a very sharp knife and just place it onto the pads there. Ideally you want to be in the centre of the two, and then just press down firmly. This is a sort of a cutting mat type of thing. So just place it there, press down firmly, and then it just cuts through like that. You can use sort of side cutters, but the problem with that is it tends to chew the plastic a bit and leaves a rather nasty edge. So you want to leave pads on both halves, so at least you've got some chance of soldering to it when you want to use the next length. Now when it comes to actually attaching wires to the tape, they're going to need a couple of items, one of which is a soldering iron. Here's a typical example. Plug it in, the end heats up, and of course you need some solder to go with it. Now of course solder these days is supposed to be this stuff, which is this lead-free business, which unfortunately is extremely difficult to use and not very nice because the fluxes in it are extremely toxic, but nevertheless lead-free solder is a thing. You want to buy it so it's fairly thin, like this one. Do not buy the stuff for plumbing purposes because that's far too large and quite frankly be impossible to use. And you also want the one with a flux inside, which again, anything designed for electronics use almost certainly will. This one is called a 99C, whatever that is, but this is just basically your lead-free solder, and it says do not breathe in the fumes and so on and so forth. But because lead-free solder is rubbish, we're going to be using this solder instead, which unfortunately does have lead in it and is 10 times easier to use and does a much better job. Now, so we can actually see this, I've zoomed in a lot, and this is the same tape here, so this is only 10mm wide, but of course it looks much bigger on this screen. Now, so this is the RGBW, so we can see there we've got the 5 pads there, common positive there at the top where it says plus 12 volts, and then we have our green, red, blue and white connections, and you can probably just about see from those the tracks under that white covering, which of course go along the whole length of the tape, going to each LED as we go. And you see the first LED there, again it's marked with white, blue, green and red, but doesn't actually matter because we're not soldering to that directly. But you can see in the top there that the white is the one on the left there with that sort of yellowy covering. That's going to be a phosphor. And then the blue, green and red are just individual blue, green and red elements which give out that colour only. A couple of resistors there, which is what limits the current through the LEDs. And then of course as we go along further there's another LED there. A couple of resistors and another LED, and then there's the next cutting point. So you could cut there and obviously join to the next one, and it just basically repeats all the way along pretty much until you get to the other end where it's the same thing. Now of course you can connect to both ends of the tape, but do bear in mind if you're connecting to the other end it's in the same order this way round, as in common at the top, green, red, blue, white, but if you put it the other way around for soldering, notice it's upside down, so just be aware of which way up it is when you're connecting to it, because obviously in this case 12 volts is at the bottom, and if we go to the other end, of course 12 volts is at the top. Now in terms of soldering to this, we need to fix it down in position. Now you can buy fancy overpriced clips and things to do this, but easiest way is just get some tape. It's just a masking tape, and just place some tape over it like that, and then of course held in position, so nothing problematic there. Another reason why I want to do this, say at home or in workshop or something, because obviously it's much easier than trying to do it while it's hanging out of the wall or something. Now soldering isn't particularly difficult. The noise is the extractor, because we don't want to breathe in the fumes, so you'll need a soldering iron with a fairly small end. That's sort of reasonable sort of size there. Solder, of course, we saw before, this happens to be the leaded variety, and some kind of cleaner. This is a sort of brass material here. Now before you start, you just want to apply a bit of solder to the end of this here, just to coat the end of there, and then just scrape some of that off into the brass material. Now traditionally this was a sponge with water in it. Not really recommended at purposes, because it tends to cool the end obviously, and may lead to corrosion if it got too wet. But essentially what you want to end with is the end of the soldering iron looking nice and bright and shiny, with a nice even coating of solder on it. Now the smoke you see there pulling off and just going away into the extractor there is the flux that's inside the core of this solder, and that's what actually cleans the metal as it's being put on there. So just clean off the end of that, and then the nice shiny end is what we want. Now first thing to do with the tape is to apply some solder to these pads here, because these are basically just bare copper. It's not going to be easy to solder this and the wires at the same time, so we just want a coating of solder on there. It does want to be very thin, so we don't need a huge amount of it. And note the size of the solder here relative to the pad. You see that it's very thin. It's actually narrower than the pads themselves. Soldering bit, you see, is quite large relative to the pads. It's actually a bit bigger, but it won't actually matter, because the solder will only stick to the copper areas. It won't stick to the white material in the middle, which is called solder resist or solder mask. So it's only going to stick to those there. So the general idea here is to apply the solder to the surface here, put the iron along the top, and then just bring the solder and the flux across all of the pads in one go. What you don't want to do is to apply the solder to the iron and then try and apply it here, because then the flux will have burned away and obviously won't do much of a job in getting onto there. So this is something you'll just have to practice, but once you've done it a few times it's fairly straightforward. So there we go, we've got solder on all of the pads there, and as you saw it doesn't actually stick to the white material, so you don't have to sort of get in there and try and carefully place it on each one. Just drag across the whole lot and it will magically fit into place. Now we need to attach some wires to this. Now you can buy 5 coloured flecks on the end of these. It actually comes with it in many cases, little short pieces. You can also use that if you want to. And another alternative is this stuff here. This is actually category 5E network cable, and this is what you get inside. Basically it's 4 sets of twisted cores. Now this is quite handy because it's about the right size, and conveniently it comes in the right colours. So you see there we've got green, blue, orange, which will do for the red obviously, and then brown. We could also use that for white if we wanted to, and we'll need another piece for the common, but we just use the white pieces for that or whatever. So that's certainly a nice option. You can either just use, say, the coloured bits on their own, or if it was, say, a long piece, you could, so like the green here, you could just use the green and the white with the green stripe just twisted together onto the single pad. In this case we're just going to use a single colour because just a small bit for demonstration, but we'll just get some of these ends stripped, and then we'll go about connecting those to the pads at the end of the tape. Now just as with the pads on the tape, we want to apply some solder to these things before we try and join them together. That just makes it 100 times easier when it comes to actually fixing them together. So same thing as before, make sure the end of the soldering iron is nice and shiny, just a thin coating of solder there. If it doesn't have that, just apply some and then just clean it off on the wire brush item we had before. And then we want to basically apply the soldering iron underneath, or at least on one side of this, and then apply the solder to the other side. So we're actually applying the solder ideally to the metal, not the soldering iron, and taking it over there. So we'll just go underneath there, apply the solder, and then that should heat onto the metal. You can just cover that over thoroughly like that. So see there, we've got a very thin coating of solder on the metal there. Didn't go right to the end, but it doesn't matter because we're going to be trimming that off in a moment anyway. Now going back to our pads, we see that the strip section is somewhat long, so we want to cut this so it's ideally about the right length just to go to the end of the pad. We don't want to be doing it like this because then there'll be a huge amount here of bits sort of overhanging, which we don't want. So we want to get the insulation reasonably close up to the end of that, but again not so much that it's sort of hanging out over here. And again, we don't want to have the insulation hanging over the pad either. So we'll just trim that down with some cutters to an appropriate length. So as you can see there, that's a more sensible length. So when we place it down onto the pad here, it's going to be the same sort of size as the pad, and it's not going to have any length sort of shorting out onto the adjacent pads. Now just doing this with a single wire here, if you're doing the one with the 5 in it, what you want to do is to prepare the ends of all 5, because they're generally joined together, cut them all to the same length, and then when you place it against here, it'll actually line up perfectly with all of those, and you can do them all at the same time. Now again, I'm only doing the one here, but once you've done all of the conductors there, what you do is just place the wire over the tape so the two soldered parts are basically touching there, fix it down with a bit of tape or something, and then the only thing to do is to basically to join them together. What we're going to do is just to heat these two and just press down so that the solder will melt, flow together, and then remove that and it will then cool into position. We don't need to apply any more solder because we've already got plenty on the pads there. So it is just a question of going in there with the soldering iron, just pressing down on the top there. That will heat those like that. Take that away, and that is now joined completely together. So it really is that quick. It's not like I've sort of heated up for ages or anything, just literally a second or so, and then that will join together like that. Now for this one we need to repeat that obviously with the other 4 individual wires. So if you'd had a multiple with the 5 in, you could actually do them all at the same time, just line them all up and then just press on each one individually. Main thing to assure here is you're not putting so much solder on that it's actually going to overlap. That's why we put the solder on to start with, so we had a sensible quantity and we're not actually applying any more solder at this stage. So that's all 5 wires connected to that. So we've got the common as that sort of white one, and then we've got the green is green, red is the sort of orangey red, blue is blue, and I've used the brown one for the white. And we can also turn off the fan there, as that is the soldering complete. Now the main thing here is to make sure that you haven't actually shorted between any of the pads there. If you've only put the small amount of solder on initially and then just press them together, that shouldn't happen, but just make sure that there isn't a short there. If you get a short between the positive and any of the others, then nothing will work. Luckily the power supplies generally have short circuit protection built in. If you're short between any of the coloured ones, then you'll find that when you turn it on, those two colours always turn on at the same time. So say green and red were shorted, you'd find it was always yellow. You couldn't get red or green separately. Now I do need to cover the end of this. There are various options here. This is a fairly weak connection as it is, because this is a very thin tape and they're very thin wires. So what we're going to do here is just put some black insulation tape over the whole lot. You could use heat shrink if you wanted to, but be careful there because it may sort of roll the tape round into itself. Another option is to put some hot glue over the connections and then heat shrink over the top of that. So various options there, you can use whatever you basically would like. But in this case, we've just got some black insulation tape here, cut the ends fairly square, so we're just going to place that over the top of there. Press it down firmly so it basically goes into the actual areas of the wires there, and then we can fold it around the back. But what we are going to do is just remove some of the backing tape here, so that would also make it easier when it comes to install it into the track. So just peeled away some of the backing tape there, and then the tape can go over the back. Again, press that fairly firmly at the end there to meld those together, and then just fold the excess around the front again, and again over the top like that. And then these can connect to whatever else you've got. If this is going into an actual installation, so you could put some heat shrink or something over these to tidy those up. And then the ends of these, generally what you want is within the installation itself, prior to it being plastered in or whatever else, what you'd want is to have some, say, 5-core flex installed in the walls, whatever. Then when you get there, all you've got to do is just to cut these to the appropriate length on the flex, join the two together with, say, solder, crimps or whatever connectors you might like, and then just place the track or the tape into the track that's already in the wall. Now this is the other end, of course, which we didn't solder, and if you were going to put the feed from both ends, you just repeat the same thing at this end. If you're not going to be using the other end, you can just leave it as this. However, there is a possibility that these copper pieces here could end up being shorted onto the aluminium backing. It is fairly unlikely because aluminium generally gets an oxide coating over it, which isn't very conductive, and plus these are only on the top side. However, to prevent that from happening and therefore shorting out the thing, good idea just to peel away some of the backing piece here. So just peel away some of that backing, and then at this end just place a piece of tape on the top there so it goes over the contacts. Fold that around the back so it obviously overlaps at the end here, and then just fold the piece over that. So it's just protecting the end of those so it's not going to get shorted onto the actual aluminium backing or whatever else you've got there. So just covering over like that. Now to test this, obviously a good idea before you put it in there to make sure there's no short circuits or whatever, then just need a 12 volt power supply. We're just using this bench power supply here, which we've set to 12 volts DC. Two connectors here, got the positive which connects to the common lead, that's that white one we're using, and then the negative connects to one or more of the coloured wires we have there just coming out of the end. So this is the red one, or it's actually an orange here, so we connect this here, then we should get the red ones lighting up, so just connect that there, and then there's our red illumination along the length of that, and basically just check that it's actually lighting up in the right colour, and it's actually lighting up all the way to the end of the strip. And we try the other colours. Here's the green wire, so connect that there, we should see the green. So yeah, there it is. And again the blue one, let's connect there, and again there's our blue. And then the white one, this is a cool white on this one, and then there's the white coming out like that. And I've got a bit of the plastic cover here just to give an illustration of how that would look, so you just place that over the top there. So again we just go for the red. So there's the red, so you can still see the dots through it, but again it just diffuses it out a bit. So generally have this out of sight, so under a cabinet or whatever, so you don't actually see the thing directly, it's just illuminating the surface below. There's the blue, and of course the green and the white we saw before, and the other colours are achieved just by mixing these together. So if we get red and green together, that should be a yellow. So there's the yellow, and if we go for red and blue, that's some sort of horrible purpley colour. And we can also have various colours with the white as well, so it gives you like a lighter colour, pinkish white there. Green and blue together gives us sort of a cyan of met, and that's all three of the colours together, as in the red, green and blue. And again that's sort of white, not necessarily the same white as that. And of course you can have the white with all of the colours together as well, which gives you something like that. So that's pretty much at its full brightness there. Now when it comes to wiring these things in theory you can just use the little grotty connector it comes with and just shove it in there, just a push fit thing. The trouble with that is it can sort of undo itself as well, and obviously if you already cut the end off, want to use another strip, not particularly practical. So what you can do is just open these up. It's just a little plastic case with not a lot in it, and then we can see what's inside. This is the infrared sensor. This is an infrared version, so this has to be in line of sight of the remote control. You can also get these in a radio version, which means you can just put this somewhere in the room out of sight, and then as long as the radio signal reaches it, well, that's fine. This thing you can actually cut off and just use the cores inside, or if you wanted to you can just solder directly to the board here. And again, these are super easy to use because if you have a look on the circuit board here, you'll see it is actually marked with the appropriate things. So at the top here we've got the common. Now it says VCC, that's basically just the positive connection, and as I said earlier, bearing in mind that this is actually black in this wire, but that is actually positive. And then we have white, which they've used a yellowy orange colour for, red, green and blue. Now for some reason this one has the red and green swapped around, because clearly obviously R isn't green and G isn't red, so goodness knows what they're making of that. But I have actually used a few of these recently, and yes, it is swapped around, and the one that says R on the circuit board is red, so if you connect red to the red one on this you'd get green, but that's just cheap manufacturing for you. But you can either just use this bit of cable here, just say strip the ends off and connect these to your existing wiring or whatever, or you can just chop all these off and solder directly to the 5 points on there. Either way, doesn't actually matter. And all that's going on here is most of this side here is the circuitry to deal with the infrared receiver and little microcontroller there which will just receive those signals and decode them into obviously changing the brightness and whatever. And then the output is just on these 4 transistors, which are just varying the voltage up to 12 volts to adjust the brightness of the 4 colours. So there's not a whole lot to this. Basically, if it's at 12 volts, then it's at full brightness, and if it's at a lower brightness, it just reduces the voltage to some lower value. So very simple and straightforward. But do be aware of some of these have the colours all the way around. So if you plug it in and find that when you press green it comes out red, and likewise just swap around the 2 wires for red and green, it's not really a problem. Now this has this sort of barrel connector which you're supposed to shove your 12 volts into. You can use that of course, or just solder on the back here directly to the terminals in question. It's fairly obvious to work out which is which. That one there, you can see it goes across over to the common there, so you know perfectly well that that is going to be the positive. So positive that one, and of course negative to the other one. This has 2 negatives because it's just one for support, but basically it's positive there and negative there. So just solder on a cable to that one directly and pop this back in its box, and that's pretty much it. So let's look there at LED tape. Relatively straightforward to use. Just remember that the common is generally positive, and in many cases you can ignore the colours of wire, particularly if it's supplied with it, because they of course can be wrong, and in which case you're going to find that the colours don't match up with the remote. Now that particular one we had there was a fairly cheap one. That's just an infrared thing, so you can get the radio control ones as well. You can also get higher power ones which have screw terminals to connect the various wiring to as well, rather than the little bit of wire coming out like that. But again, just a question of buying what's appropriate at the time. But certainly worth knowing to sort of cut it up and make it into custom lengths or whatever, because generally you don't want to be using the whole length in one piece unless your room happens to be exactly 5 meters in length. So that's it for this video. Until next time, thanks for watching.